Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. Today we're going to learn on type of advanced controller. In designing control system, there are several variables that need to be identified prior to designing. For example, the first variable is a control variable. So, alright. So for example, in this figure, it depicted the heat exchanger figure. All right, the control variable or the variable that we want to uh, maintain at certain set point is the temperature of sterilized saline. So this is the control variable. So by definition, the control variable is the parameter that indicate product quality or the operating condition of the process. All right. So how do we control the control variable is by manipulating a certain variable. All right. So in this case, the manipulated variable is the saturated steam. All right. So in order to control temperature of saline water, we need to regulate or manipulate the saturated steam. So by definition, manipulated variable is a process being adjusted by a final control element such as control valve, damper, and motor speed. Okay, and then there must be some disturbance or load variable that affecting the system or affecting the control variable. All right, so for this example is the inlet flow rate or inlet temperature of the saline water itself. All right, so by definition, load variable is the all other affecting variable other than the one being manipulated. So that is the disturbance or the load variable. And another characteristic or terminology that we need to really understand in designing control system is the set point. So what is the set point? So set point is the desired operating condition. For example, in this case, we want to maintain the temperature of saline water at 80 degrees C. Feedback controller is the type of controller that we used to learn in previous lesson. So this type of controller has been used ages and still being the most common control system used in industry. So what exactly a feedback control? A feedback control is a method to control that the action taken is based on the past result. So the controller will learn any disturbances that happen in the past and calculated in the controller, and the controller will make a decision for the final control element or the valve to make a decision based on the past cases. So what is the advantage of the feedback control? It is a simple design and it is easy to tune, especially for linear and fast and short processes. The example of the process that usually use feedback control is flow, flow processes, level, and also pressure. There is some disadvantages of using feedback control, which is it has a slow recovery, especially for a slow processes. For example, the temperature controller, because upon the load disturbance or changes in set point, a process with long dead time may exhibit oscillatory process response with long settling time. So the disadvantages of feedback controller for the slow processes such as the temperature, it has a very long dead time and it causes the oscillatory process response curve. So the process may behave like this. All right, so this is the example of the heat exchanger. The process is saline solution at 30 degrees C is sterilized by heating the solution in heat exchanger system to 80 degrees C. So the temperature of the sterilized saline solution is maintained by regulating the control valve of stream input of the to the heat exchanger. So in designing the feedback control in heat exchanger, this is the certain variable you need to identify prior to designing. Okay, now we look into the other type of the control system. In this case is cascade controller. So formally in single loop control, the controller's set point is set by an operator and its output drive a final control element. For example, for a temperature controller, driving a control valve to keep the temperature at its set point. But differ to the cascade control arrangement, there are two or more controllers, of which one controller's output drives the set point of another controller. For example, in this figure, the temperature controller. So the temperature controller will drive the set point of the flow controller, okay, to keep the temperature at its set point. And then the flow controller in turn drive a control valve to match the temperature with the set point of the temperature controller is requesting. So in cascade control, there are two loops, which is the inner loops. All right. Alright, the inner loop of this controller is the flow controller. This is the inner loop, alright, also known as the sleeve controller. So this is the inner, and it consists of the other loop, which is the outer loop. So the outer loop, in this case, is temperature, also known as the master controller. Another term used for the outer loop is the primary, and another term used in inner or sleeve is the secondary. And the advantage of the cascade control system, it has a faster recovery as compared to the feedback control, whereby the disadvantages of using cascade controller is controllability will be worse than CISO if both controller were not properly tuned. In cascade control system especially, the inner loop must react or respond in faster mode rather than the outer or the master loop. So any other disadvantages of the cascade controller is it requires an additional measurement. As compared to the feedback controller, it only have one loop. So it only has one transmitter and one controller, whereby for the cascade controller it has another two set of the temperature transmitter and another two set of the controller. So it gives the additional measurement of to the works or to the system. Another one is it has the control strategy of the cascade controller is more complex. It's more complex than the feedback controller. Alright, so that is the disadvantages of the cascade controller. And then when the right time for us to use the cascade controller. So basically, cascade control will be used if we have a process with relatively slow dynamics. For example, the level, temperature, and composition and humidity, liquid or gas flow, or some other relatively fast processes that has to be manipulated to control the slow process. For example, changing cooling water flow rate to control condenser pressure, or changing steam flow rate to control heat exchanger outlet temperature. So in both cases, flow control loop should be used as inner loops in cascade arrangement. And another one is the when cascade controller will be used or will be useful when we want to transform from CISO, single input, single output, to cascade strategy if faster recovery time is desired. Now we learn on the other type of the control system, which is the feed-forward controller. So basically how feed-forward controller being developed is basically the mathematical equation in the controller has been developed based on the process model. So we need to identify the mass and energy balance of the process prior to designing the control system or the mathematical model in the controller. As compared to the feedback controller, the information or the input of the controller is coming from the past event. So you need to identify the input or the signal from the past event in order to develop the mathematical equation in the feedback controller. So basically, the characteristic of the feedforward controller, it measures a load variables online, and then utilization of the computational box. This is the two characteristics defining the feedforward control. And then we move to the advantages of the feedforward controller. So basically, feedforward controller has faster recovery than the cascade or CISO or feedback controller. It compensates for disturbances before they affect the control system or the control variable. Because in this feed-forward controller, we basically learn the process based on the process model. So it has to be precise in order to avoid any error or deficiency of the feed-forward control. And these advantages of the feed-forward controller is it cannot work if any of the sensor fail, especially the load variable. And it requires process model in order to design feed-forward system. Hence, it has to be very precise, remember, as I mentioned earlier. Another type of control system is the feed-forward or feedback control. So basically, it is a combination of these two controller, feedback and feed-forward controller in controlling one variable or control variable. So what is feed-forward or feedback controller? So basically, feedback composition added to the feed-forward control. So basically, we want to overcome each other disadvantages by combining these two control system. So merit of the feed-forward or feedback control is feedback control compensate for major disturbances, while feedback control compensate for all other disturbances. So each of the control system cover each part of the disturbance. So you can see from this figure, so the input signal from the control variable will be sent to the summing point. So and if you can see from this is the feedback control system, whereby the flow transmitter and also flow controller here is learning from or receiving its signal from the feed-forward control strategies. Ratio controller. So what is the ratio control? The ratio control architecture is used to maintain the flow rate of one stream in a process at a defined or specified proportion relative to that of another. So the common application for ratio control is to combine a blend of two feed streams to produce a mixed flow with the desired composition or physical properties. So what is the advantages of the ratio control? It keeps to flow in proportion. whereby it in the disadvantages of the ratio controller, it inherits PID characteristic. Ratio controller basically a type of the feedforward control. So as mentioned earlier, the objective is to maintain the ratio of two variables at a specified value. So one variable is manipulated to keep it as ratio of another. So it implements two basic schemes, which is the multiplier and also divider. So multiplier or multiplying relay is the mixed ratio represented as an adjustable parameter on the operation display and is thus more readily accessible for change. And for a divider or a ratio relay is the mixed ratio is entered once during configuration and is generally not available to operations staff during normal operations. For example, in this figure, it has two input streams. So in order to control these two streams, stream A and also stream B, we can use or we can apply a ratio controller in this control system. So basically we need to blend two liquid stream A and B in some ratio. So the ratio given is here. R is the ratio equals to the flow rate B divided by flow rate A. In order to imply ratio controller in this stream, basically both stream A and stream B must be varied because stream B must be varied as flow rate of stream B is varies. So this is the multiplier or a set of ratio. So remember a ratio given in previous is FB divided by FA. So measuring the flow in stream A and then multiplying it with the desired ratio to obtain the required flow rate in stream B, whereby the set point to the flow controller of stream B. So if the flow of stream A varies, the set point of the controller of stream B will be vary. So these two streams will be flow in the same variation as two streams will be varied. A divider implies here divide in this stream A and also stream B in FY16 to obtain the actual ratio flowing through the system. So the ratio of the stream A and stream B is given by this equation. The calculated ratio is then sent to the controller, which manipulated the flow B to maintain the set point. And the set point to this controller is the required ratio of the ratio controller. Figure shows in the slide is how we draw the block diagram for every each of the controller. So the top of the figure shows the feedback control block diagram. So the input signal from the process or input signal is the control variable will be sent to the transmitter and then sent back to the controller, and then controller will take the corrective action to regulate the final control element, which is the control valve, and to correct the control variable that deviate from its set points. So this is how the block diagram look like. And then we move to the second type of the controller, which is the feedback controller. So feedback controller, basically it is developed from the process model. So basically we identify the process model. Okay, the signal will be sent to the feed forward controller, and then it will take a corrective action in order to correct the control variable that deviates from its set point. So this is the loop of the feedback controller. And then for the cascade controller, remember cascade controller consists of two loops, which is the inner loop, also known as the sleeve, or the secondary loop, and also the primary controller or primary loop, or the master loop. All right, so the inner loop will be connected to the primary controller. So this is how the block diagram for a cascade controller will be look like. In brief, we can identify the feedback controller as the controller that made a corrective action to the process. And the characteristic of the feedback controller, basically it is a robust type of controller other than the other type of controller, because the feedback controller consists of the controller that have a simpler design rather than the other type of controller. So it measures, decide, and also control the process in the chemical process plant. The process variable consists of the control variable and manipulated variable. So basically for the feedback controller, the configuration or the input output of the feedback control system, it only consists of the single input and also single output. So this is the CISO is the configuration of the feedback controller. So basically, feedback controller has been vastly used in process in industries more than decades, and it has a capacity that is simple and effective for most of the industry. That's why it maintained as the most commonly used feedback controller to most control programs. Feedback controller, it design is very simple because it consists of the single loop and it rejects certain disturbances at certain extent. That is also cause this type of controller a drawback, because this is the limitation of the feedback controller, because it only can or manage to reject disturbance at certain extent. That's why we need the other type of the control system in order to overcome the limitation of the feedback control system. So the limitation of the feedback controller can be overcome by the use of the other type of the control system. For example, what we have learned before, the control system that available in the industry and has been used by many is cascade control, feed-forward control, and ratio control. So basically, the characteristic of the cascade control, it reduces the effect of specific type of disturbance. So it is good to overcome the limitation that has been caused by the feedback controller. The other type of the controller that can maybe apply in the industry is the feed-forward. Because for a feed-forward control, the mathematical equation in the controller has been developed by learning the process model. So the general methodology for compensating measured disturbance. So we learn from the ideal process model in order to develop the feed-forward control. And then for a ratio controller, the ratio reduces the effect of feed flow rates changes. So basically for ratio controller is more suitable to be used in order to control a two flow rate into the process. To enhance your understanding on the other type of controller, try to solve this question. So basically, the question is to ensure that the level in the tank remains at or near the set point. So you need to propose the following control strategy in the system. First, you need to try to propose a feedback control in order to control the level in the tank, and then move to the second type, which is the feed forward, and also combination of feedback or feed forward in the system to control the level in the tank. So you may need further clarification or explanation. If you require this kind of information, you may refer to the to our textbook. That's all for today. Thank you. Assalamualaikum warahmatullahi wabarakatuh, and have a good day all.